You know, so many of us have these amazing memories of the Super Nintendo. That classic console, the satisfying thunk of a cartridge sliding in. But what if I told you that behind that simple fun, there's a level of complexity that is, well, it's just staggering. Today, we're going to pull back the curtain and look at the code behind the cartridge.
I want to start with just one number, 70,000. If you were to deconstruct the source code for one of the most famous games on the console, Super Mario World, that's about how many lines of code you'd find. 70,000.
And that really is the big question here, isn't it? It just sounds like a ridiculous amount for a single game on hardware that we think of as, pretty simple these days. So how is that even possible? Well, let's dig in and find out. Okay, our investigation begins with our first major clue, and that is the language these programmers had to use. It was a completely different world from what most developers work with now. Back then, games were almost entirely written in something called 65C81 assembly. And the key thing to understand here is that this is a low-level language. What that means is developers weren't giving the Super Nintendo big general commands. No, they were giving it tiny, microscopic, step-by-step instructions for every single thing the processor did. This analogy, honestly, explains it better than anything. Using a modern, high-level language is like telling a professional chef, hey, bake a cake. They know what to do. They have the skills, the recipes, the tools. But using assembly? That's like telling someone, okay, first open the cupboard. Now, take out the flour. Now, measure exactly 2 cups. Now, put it in the bowl. You have to spell out every single action.
And that difference, it has a massive effect. Take a really simple bit of math, like x equals y plus 5. In modern code, that's just one line. But in assembly, that one idea could explode into 4 separate lines. You had to tell the processor to first clear its last calculation, then load the value of y, then add the number 5, and finally store that new result in x. Now, just imagine that level of detail, but for everything. Every jump, every coin, every single Koopa Troopa. You can see how the lines of code would just pile up incredibly fast.
So that brings us to our second big clue. Because it wasn't just the language that was so granular. It was what they were forced to build with that language.
If you're a game developer today, you probably use a game engine like Unity or Unreal. These things are amazing. They handle all the foundational stuff for you. But Super Nintendo developers, they had none of that. They were coding on what's called bare metal, which is a fancy way of saying they had to build absolutely everything from scratch.
And just look at what everything meant. We're talking about the entire physics engine that governed how Mario jumped and how gravity felt. The rendering engine that drew every pixel to the screen 60 times a second. The collision detection that knew when you stomped a Goomba or hit a block. The animation system, the enemy AI for every single bad guy. The audio engine for music and sound effects. Even just handling the input from the controller. All of it had to be coded from the ground up in that super detailed assembly language for every single game.
And now for the part that just blows my mind. They had to fit all of this, all that foundational code plus the actual game itself into just 128 kilobytes of working RAM. To give you some perspective, that's less space than a single tiny low-resolution photo you'd take on your phone today. The level of optimization and efficiency required is it's almost impossible to wrap your head around.
And if that wasn't hard enough, here's another layer of difficulty. Most of the game's code wasn't even loaded into that tiny amount of RAM to be run from there. No, it was executed directly from the ROM chip on the game cartridge itself. The best way to think about this is like a musician being handed a piece of sheet music and told to perform it live on stage perfectly the first time they ever see it. There's no practice run. The code had to be flawless and ruthlessly efficient because there was simply no room for error.
So, okay, let's bring our 2 clues together. We have the incredibly verbose language, and we have the fact that they had to build entire worlds from scratch. And this leads us right to the reveal.
And there it is. That's the solution to our mystery. You take the incredibly line-heavy, detailed nature of assembly language, and you multiply that effort across every single one of those systems we just talked about that had to be built by hand. That's it. That's how you get to 70,000 lines of code for a game like Super Mario World.
Now, of course, these developers were also pragmatists. They were smart. It wasn't always 100% assembly language. For parts of the game where performance wasn't as critical, think of something like a title screen or a menu. They would sometimes switch to a higher-level language, like C. It was just faster to write. It really shows they were always thinking, always using the absolute best tool for that specific job.
So what do we take away from all of this? I mean, it's easy to look back and just see the difficulty, the struggle. But I think it's better to see it as a showcase of just unbelievable talent and craftsmanship.
It really is a testament to the incredible skill and efficiency of those early programmers. They weren't just writing code, they were building entire interactive worlds on hardware that, by today's standards, had the most extreme limitations imaginable.
And that kind of leaves us with a final thought to chew on. There's no question that modern developers stand on the shoulders of these giants. They can create things those early pioneers could only dream of, thanks to all the tools we have now. But it does make you wonder, in gaining all of that power and convenience, has an element of that raw, bare metal craftsmanship been lost along the way? It's something to think about.